Alright, this video is more on algebra review that you need to know before taking calculus. And the topic of this video is completing the square. And what's completing the square? Well, you know that if you have a quadratic expression like x squared plus 6x plus 9, that this factors as x plus 3 in parentheses squared, right? And completing the square asks the following question. Suppose that you had something like x squared plus 8x. Now this is not something in parentheses squared. Well, it's certainly not of the form x plus a constant in parentheses squared. That's what I mean. But it turns out that you can add something to it that will produce a perfect square trinomial. A perfect square trinomial is a sum of three terms that's a perfect square. And the question is, what number goes here? And it's a number, like 7. What number goes in there that will let you factor this quadratic into a perfect square? That's the question. And here's how you do it. So before we go into the steps for how to do it, let's think about, remember when you have an equation, it goes both ways, right? You can go from here to here and from here to here. These two are the same. So let's take a look at this expression. If I have, so the question is, what is the question mark that will produce a perfect square? And, well, we want to make it look like x plus a constant in parentheses squared. What do you get when you distribute x plus c in parentheses squared? It's x squared plus 2cx plus c squared. Right? Because you distribute the x plus c across. And now, using this fact, we have x squared plus 8x plus something. This should be a perfect square. This should be x plus something in parentheses squared. Right, this is your c. The number that we're looking for is the question mark. Now look at what you have above. So I'll get rid of these underlines. Right, we're trying to figure out what the question mark is, but we know that we have this general fact here. So we're trying to figure out what goes in the question mark, and we'll also figure out c that makes the thing on the bottom, this equation, match with that. And if you look at the coefficients of x, the coefficient of x is 2c, that's being multiplied by x, and the example that we have, 8 is being multiplied by x. So if you want to match these two equations, then we have to have that 2c is equal to 8, because they're the coefficients of x. And therefore, c is equal to 4. And now we see what goes in the question mark, because the question mark is c squared. So the question mark number is, right, the number we're trying to figure out is c squared. That's 4 squared, which is 16. And so we figured out that if you add 16, you get a perfect square. And we actually figured out what you have to add to x before you square it. It's c, which is 4. And this is a true statement. X squared plus 8x plus 16 equals x plus 4 in parentheses squared. Now let's think about what you would do in general. So let's say that you had x squared plus bx, and you want to add something that will produce a perfect square. Now the number is going to be in terms of b. So b is some number, right? It's just that it's not 8. It might not be 8. We don't know what the number is. We're trying to figure out what to add in general. And we again use the same fact that x plus c in parentheses squared is equal to x squared plus 2cx plus c squared. And we have x squared plus bx. And we want to figure out what to add and how to factor it into a perfect square. And again, if you match these two equations together, you see that b is going to equal 2c. So therefore, b is equal to sorry, what wait, no, we just figured out that b is equal to 2c. Oh yeah, okay, yeah, b is equal to 2c, right. So therefore, what is c equal to? Therefore, c is equal to b over 2, because you just divide both sides by 2. And now we know what the question mark is. The question mark is c squared, right? Just like before, c squared, and c is b over 2, and when you square that, you get b squared over 4. And remember, I'm skipping a step here. This is b over 2 times b over 2. So it's, it's like b over 2 times b over 2, and then you multiply the numerators and denominators, so it's b squared over 4. Okay, so c squared is b squared over 4, and so that's the question mark. And so we now know that if you add b squared over 4, that this will produce x plus b over 2 in parentheses squared. And this process is called completing the square. So for instance, if the question is complete the square, x squared plus 5x, then your b is 5, right? And we just need to add b squared over 4. And b squared over 4, well, let's figure out c. So c is going to be 5 over 2, right? And then when you square it, b squared over 4 is 25 over 4. So we know that we get x squared plus 5x plus 25 over 4. So that's completing the square. It's just adding the thing that we need to get a perfect square binomial, and this is a trinomial, and this is x plus 5 over 2 in parentheses squared. Okay, but b can be any number. I mean, b doesn't have to be, right? That's the nice thing about knowing this formula. It's that it works no matter what b is. B can be any real number, and this statement that I just boxed is true. Okay. Now, one thing we should talk about before we go on is what happens if the coefficient in front of x is not 1. So for instance, let's say that you had, I don't know, 2x squared. Let's actually, before we do that, let's actually do something maybe a little easier. Let's say that you had 4x squared minus 3x. And again, you want to add something that will produce a perfect square. Well, here, what we had before is not going to work literally speaking, because if you took x plus b in parentheses squared, right, if you took this and square it, the coefficient of x is going to be 1. And we want something where the coefficient of x is 4. But what you can do is pretty much the exact same thing, except that in squaring x plus c, you take something like, okay, I don't want to, let's see, what's a good letter to use? So I don't want to use a, because a usually is what's being multiplied by x squared. So let's use e. Sure. So you have ex plus c. Well, when you square that, okay, let's just write it out. When you distribute this, you get e squared x squared plus ex times c plus c times ex, so that's the same as 2cex, and then plus c squared. Okay? So this is ex plus c in parentheses squared. Now here we have, in our example, we have 4x squared minus 3x plus something equals something x plus something squared. And we want to figure out what the numbers in the blanks are. And we see that, okay, let's just write out what we have. The coefficient of x squared is this, and this is the coefficient in front of x, right? And so we know that e squared equals 4. Well, that tells you that e is either 2 or minus 2. Since we just want to factor this, we just want to add something to produce a perfect square, you know, negative 2 will work, but 2 is easier, so let's just use, so either will work. Let's use e equals 2, the positive one. So if e equals 2, now we also know from setting the coefficients, you know, in the blue equal to each other, 2ce is negative 3. Well, if e is 2, then that gives you this, and that tells you that 4c is equal to negative 3, and so therefore c is negative 3/4. And so c squared, the number that goes here, c squared is 9/16. And so we just discovered that if you make e, so here's e and here's c, if you make e equal to 2 and c equal to negative 3/4, you will get a perfect square trinomial. So we figured out that it's 2x plus negative 3/4, that's 2x minus 3/4 squared equals 4x squared minus 3x plus 9/16. And if you distribute this across, you'll see that this is in fact true, right? So we just discovered that if you start off with 4x squared minus 3x and then add 9/16, that factors into this perfect square. So that's completing the square. So a lot of videos explain completing the square, but they just tell you that you take, like for this one, a lot of videos will just tell you, probably a lot of math teachers, will just tell you that you take the 8 and you divide by 2 and you get 4 and then you square it and you get 16. But here we explain why you do that. It's because of this equation, and by matching it with what we had before, the x squared plus 8x, and then seeing that c has to be 4 in order for it to work, and then c squared is 16. And we explained how to do it if you just have, you know, if the number in front of x squared is not equal to 1, right? Okay, it's a bit more complicated, but it's pretty much the same idea. So that's completing the square. Oh yeah, before we go on, why is it called completing the square? Because, so why is it called completing the square? Let's say that you had x plus 3 in parentheses squared. this is equal to x squared plus 6x plus 9. Now let's draw a little visual of this. So let's use the area, the idea of multiplying to get area. So if you have, here's x, say, and here's, let's say this length is 3. Then x plus 3 in parentheses squared, well, that's the area of this. That's the area of this square. So I drew a square, and let's say this is x and this is 3, right? So this length is x plus 3, that length is x plus 3. The area of the square is x plus 3 in parentheses squared. Now if you take this picture and then draw two lines like this and like this, right? You actually see where each of these things that you're adding come from. Since x squared is here, it's x times x makes x squared. The 6x comes from, so this part here is 3x, and this part here is also 3x, right? Because I have a base times height. And 3x plus 3x makes 6x. And now you see that if you just have x squared plus 6x, you have this shape, which is not a square. But if you add an area of 9, this 3 squared, and you add 9, you get this square, and you filled in this big square. So that's why it's called completing the square. You filled in the big square of side length x plus 3. So that's completing the square. Now the question is, what can you do with completing the square? And the answer is you can do a lot of things. So for instance, okay, one application is solving quadratic equations. For instance, let's say that you had x squared plus 6x equals 7. And you want to know what are all the x's that will make this true. Well, if the 7 was a 0, then we don't need to complete the square. We can just factor x squared plus 6x as x times the quantity x plus 6. But we don't have a 0, we have a 7. So what do we do? Well, the problem with factoring, see, factoring doesn't work. Because if you factored x times x plus 6 equals 7, now you have two numbers, x and x plus 6, and one of them has to be 6 more than the other, and you get 7. And you see it's hard to come up with what x is. There's no step you can do here easily to just figure out what x is. If the 7 was a 0, then you can use the fact, right, that when you have two numbers and you multiply them, you get 0. One of them has to be 0. That was the key fact for why, for how the method worked when you had 0. But the method doesn't work for 7 because, if you have two numbers, you multiply them, you get 7. I mean, you have an infinite number of, you don't know anything about either of the numbers. You just know that they multiply to 7. Okay. So you can't conclude that, one of them is 7 or anything. Oh, well, actually, we can see that x equals 1 is going to work. But, yeah. I didn't think of that. But the point is that there's no general method for doing this. How do you come up with a number, and then when you multiply it by 6 more than that number, you get 7? Right? There's no general method for this. So, well, we're going to learn the method. It's completing the square. We actually want to start here. And the idea is we're going to complete the square to produce a perfect square trinomial on the left hand side. So this is x squared plus, I'm just going to write it out again, except leave some space here, because I'm going to complete the square and I'm going to add what? I'm going to add 9, right? 6 over 2 is 3, 3 squared is 9. And since I add 9 to the left, I have to add 9 on the right, right? Because otherwise, I mean, you have two things that are equal. If you add 9 to one side, you have to add 9 on the other to keep them equal. And this is gonna, now you see the benefit of this. X squared plus 6x plus 9, can I factor that easily? Yes, that factors as x plus 3 in parentheses squared equals 7 plus 9 is 16. And now we have something in parentheses squared equals 16. So therefore that something is, and I'm about to sneeze, give me a moment. Okay, I'm not about to sneeze. Okay. Anyway, x plus 3. X plus 3 equals what? 4 or minus 4, right? Now remember, what I'm not going to do is I'm not going to put a square root. We're not going to, put the square root and put the square root and then put a plus or minus and then cancel. We're not going to do that because it doesn't make any sense and it's not mathematically correct. Remember, to go from here to here, as I explained in the square root video, you're using the fact that whenever you have something squared equals 16, the only solutions are plus or minus the square root of 16. I mean, if I really wanted to show every single step, I would do, plus or minus the square root of 16, and then get x plus 3 equals plus or minus 4. I'm probably just going to skip that step from now on, because it's annoying to have to keep writing it every single time. So now I have x plus 3 equals 4, and I have x plus 3 equals negative 4. And I can just solve each of them. Remember, we figured out that x plus 3 must be either 4 or negative 4. Therefore, either x plus 3 must be 4, or x plus 3 is negative 4. And so for this one, implies that x is 1. And this one implies that x is negative 7. And for good measure, we should check that these are actually solutions, because we didn't actually show that these work, right? We figured out that if x is a solution to this equation, then the only possibilities are 1 and negative 7, but we didn't actually check that these actually are solutions. So you just check. If you plug in x equals 1, and again we're plugging it into the original equation, 1 squared plus 6 times 1, is that equal to 7? The answer is yes, because on the left I have 7 equals 7. Yes, good. And on the right, if I plug in negative 7 in for x, do I get 7? On the left I have 49 minus 42. Is that equal to 7? Yes. 7 is, I get 7. And I just want to emphasize that I put the question mark above the equal sign because I'm asking whether they're equal. If you don't put the question mark, then you're just saying that they are equal. Okay, so that is solving quadratic equations by completing the square. And just to be clear, the answer is, so the solution is that x equals 1 and x equals negative 7. These are the only two solutions of the equation. Let's do one more example. So let's say that you had 4x squared equals 6x plus 5. All right, well, we have x's on both sides of the equation. We want to get them on one side. But for a quadratic, what we really want is we want 0 on one side. So we will subtract x squared and then subtract 5 to get this, to get 0. And now I need to solve this. Well, I have this, I want to complete the square, but it's helpful to instead of doing what we did before, it's better to do it like this. So before we had a constant in front of the x squared, now we have a constant in front of the x squared. But what I'm going to do is I'm going to add 5 to both sides. And now I'm going to divide both sides by 4. And the reason why I'm doing this is because I want to lead up to the quadratic formula and how to figure out the quadratic formula. And I also want to lead up to the next application, which will involve this method. So this is going to simplify to x squared minus, 6 over 4x, that's 3 over 2x, equals 5 over 4. Now I'll complete the square. So before I was just doing algebra. Now I'll complete the square. X squared minus 3 halves x plus what? Again, you take half of b. Now b is actually negative 3/4, right? Because it's, I have a negative sign. So this is x squared plus negative 3 over 2x. So my b is negative 3/4. And so I add b squared over, this is b over 2. And now I get b squared over 4, that's 9/16. So I add 9/16. And now how does the left-hand side factor? X minus 3/4 in parentheses squared, and then what do I get on the right? 29 over 16. Right? Because 5 over 4 is 20 over 16. And then I add the numerators. And now we get that x minus 3/4 equals plus or minus the square root of 29 over 16. And this, how do I simplify this? It's plus or minus, this, I have square root of 29 over the square root of 16, right? And so I get plus or minus the square root of 29 over 4. So I get x minus 3/4 equals that. And now I just need to add 3/4 to both sides. And so, and if I want, I can simplify, I can combine these into one fraction. I get 3 plus or minus the square root of 29 all over 4. Okay, well, there are a lot of steps to this, starting from here. But if you think about it, okay, how did we get from, so we just, to get from here to here, we just made 0 on one side, okay, and then we added 5 to both sides. And why do we add 5 to both sides? So that we can, when you divide by 4, right, divide by a thing being multiplied by x squared, you have something where you can complete the square. We wanted something with just x squared plus bx. And when you complete the square, you get that, and we just solved just by doing, once you complete the square, right, then we just factored, took square roots. What we're really doing when we say we take square roots is we're applying the square root fact, right? That's plus or minus the square root, and then you solve for x. So it's a lot of steps, but when you break it down, it's steps that you can understand, and you're just kind of putting it all together. Well, this leads us to what happens if you have anything like ax squared plus bx plus c equals 0. How do you solve ax squared plus bx plus c equals 0? Can we come up with a formula for this instead of doing this every single time? Doing the completing the square method every single time. And the answer is yes. We basically just do what we did before, except with a, b, and c,